Hello guys, how are you doing? Today we are in electrical circuit lecture 4. So today we will learn about AC. We know DC, right? So we will start from AC. Or if I miss the DC, I will explain, make a lecture more later, okay? Don't worry about it. So, and we will learn about the expressing way of AC, like peak value and mean average value and RMS value. What is that? We learned about it or we heard, but we don't know yet what is that, the meaning, right? So we will learn about the meaning, okay? Let's see. So here, this is a 3-page generator, right? So stator part is a coils here. It's a stick here, right? And rotor is a revolving part. So we say magnet is a revolving now, right? So we say revolving field tie. Okay, we generally use this. So as you guys can remember this, okay. Let's see. Let's read it a little bit. So I say electromotive force EMF. Okay, EMF is induced when the time goes by. If the magnetic flux is changed, time goes by, changed, this is minus, and EMF is induced. It's a Lenz's law and Faraday's law, right? If you guys don't understand what I'm saying now, go back to previous lecture, okay? I explained deeply, and I explained before. So yeah, you guys need to learn about it, okay? Okay, let's go on. So today's lecture is kind of simple. We will learn about what does that mean, okay? So look at that. As you guys can know, AC is a kind of a waveform, right? It could be sine waveform, or it could be cosine waveform. Okay, don't need to consider about what is sine form and cosine form. Okay, it depends on the situation. Where do I see the point? It could be sine or it could be cosine. Okay, I will explain more about sine or cosine part later. Okay, just by the way, these two wave is sine or cosine is a wave is we say this is waveform, right? It's not DC. DC is direct, right? So as you can see here, you can see waveform, but there's some point. For example, this is time. This part is, and you can see here T1 point here. We wanna know about this, point's value. So we say this is instantaneous value. We say, right? If we add here vi sine omega t is that is instantaneous power, right? If it's yeah, if it's just yeah, here's current and here's volt, how to get it instantaneous values, right? So let's move on more. So look at that. Here's waveform, right? And peak is we can understand right away, right? Peak is the peak point. You can see the as you can see the largest point here. Peak to peak is waveform is, as you guys can see here, from here to here is a peak to peak, and here so we say peak. And what is that RMS and average? We wanna know about this, right? So I will explain first for RMSs. Okay, so look at that. RMS means we wanna know, okay, determine the equivalent to DC value of an AC waveform. So simply, we wanna know, as you know, there's many instant values, right? But we wanna know, right now, how much like as a DC values. You know what I mean? We now want to know about the AC's values as a DC values. That is RMS. Okay, that's it. And that is we generally use RMS values when you use ammeter or whatever. Generally we use RMS values. Okay, and so you guys want to know, so what is the difference as average value and RMS? So yeah, let's move on. I will explain. So the result is first of all, average value is active power. Later, okay, all right, move on. Okay, so what happened? Sorry, guys. Yeah. So later we will learn about the active power and reactive power. What is apparent power? We will learn about later. So what I'm saying is average value is I'm saying active power. Okay, let's see. I'll explain. So look at that here. So here's we use active power. I will explain later about what is active power and reactive power. Okay, I will just want to explain why average values active power. Okay, so for example, we are using pure R register. Okay, pure load, R for example. Okay, so look at that. So we say for now this is V, and I will say this screen is I. In the pure, R load or register is we say now look at that. This is the same page. We say in page. You know what I mean? VI. So as you guys can see, power equal VI, right? We will learn about later. Okay. So it's just kind of being familiar with what I'm saying. Okay. So power gotta be I will do that like this, right? But here's look at that. Here's a VI is plus values. So it gotta be plus value, right? And here look at that. Minus minus, it gotta be plus. So actually it gotta be here. And look at that. And plus and here. And from this value, we need to mean, average value is active power. Look at that. So what I mean is V time and I time. This is the maximum value, peak point, okay? And then we will do integral calculus. So you guys actually don't need to know about it. Just I want to explain if you guys, some of you guys are interested. What does that mean? Okay. So we just need to know about, I mean, if you guys understand that this part is fine, but just memorizing the result is also fine, So if we do integral calculus and this average value is we say I cosine theta, and which means active power. Active. Yeah, that's it, guys. Today's lecture is kind of easy, right? So I generally, we actually, don't know about what does the value meaning. Like, okay, where is it? Here. Look at that. Here's what does that mean? Peak point and RMS value or mean values. What does that mean? Well, when we go to the more lecture about when you learn about like a circuit breaker, the part, we will learn about it. Why these, values we need to recognize, right? So in the, just a quick review is peak value is, as you guys, everyone knows peak, right? The largest value peak. Just we say this is peak to peak, right? Average value is active power. Just memorize, okay? And RMS value is we know AC values. AC is values, but we wanna know it as a DC's value, like straight. We wanna know the same values as a DC values. That's it. Today's lecture, guys. See you guys.